1 second, folks. Gonna send out a tweet. Hey, Abner Crombie. Wait, Abner Crombie. That's not right. Abner Cleanbray. That's it. I mixed them up. Ah, yes. Good point. This is the wrong stream for that information. There we go. That should be better. Although I am doing a short. Actually, let's switch it back. I'm doing a short 4-quarter announcement first. No, wait, not that one. Why do I even have that? Yeah, let's get rid of these. And this. And this. So let's do just nothing for now. Alright. There we go. Alright, so what I need to do right now, I can get rid of that one. That's my my one for fixing the high CPU crap. But let's do this. So the problem is, right now, I have the latest version of 4-coder, which is 4-coder 4012, which is still in development. I have that packaged as my current 4-coder. But I'm not going to use that today. I'm actually going to use 4011 that I shipped. And the reason for that is because, the features in 4012, I'm not ready to tell you what's going on with 4012 yet. So, so for this stream, we're going to keep it strictly on 4011. And if you want to know what's coming up in 4012, you'll want to check Wednesday's stream. So that's my little mini 4-coder announcement for today's stream. Is Wednesday there will be a super special announcement about 4-coder. That's today's announcement, is the coming one. Alright? So mark it on your calendars and all. Whatever it's gonna take to make sure you don't. Oops, that's gonna be the 4012 again. I gotta come in here and pull out 4011. Extract this into my other little folder. Pull out the 4-coder folder. There we go. Now we have 4011 installed. And let me go get my the power stuff hasn't changed at all, so I can use that again. Okay. And I'm still using the same settings file. Put that in there. Alright, so we are now downgraded to 4011 again. And let me pop over here and build custom real quick. Alright, 4011, where there are no special surprises to spoil. Okay, so there we go. We are all ready now to begin a Cipher Drive stream. And Mikkel is complaining in the chat that I'm a tease, but you know, the thing, we got Abercrombie here too, so we can just point out the obvious that at least you know for sure that when I said something's coming out on Wednesday, some information, you know for sure that I'm actually releasing it this Wednesday is what I'm talking about, and that I'm not confusing like the Venus Wednesday with the Earth Wednesday, right? So it will actually be on Wednesday. It's only 2 days away that you'll get what you're looking for. Okay. Now, let's take a look at Cipher Drive. Oh, I'm in the wrong, because I was just dealing with forecoder stuff. We need to go to my shmup folder. There we go. Alright, so font, TTF, yeah, tool, TTF to bump. No, not TTF to bump. Where's the, buffed? CD, what is the name of this? Is it under util? Punt RGA? No, I'm looking for... Is it tool TTF to bump? It must be TTF to bump. It's true. At least when Coinberry does deliver something, it's always a pleasure, whatever it is. That I can add as a side note. All right, so last time I was doing font packing stuff, and I haven't touched it since then, since I only do Cipher Drive stuff on rare occasions, since we're taking it slow burn style here on this project. But we're here today, so let's take a look at what needs to come next. We did all that work. We were looking at optimizing it, so all this color stuff here was about looking at the font packing, and the font packing works. We're happy with how we pack the rectangles together, so we don't need to do any of this. This is all just giving me information about the... okay, so yeah, right here I get I pack the rectangles into the output. So there we go. Now, they're packed in. What we need to do next is actually render the glyphs into a bitmap. So, basically what we need to do first is allocate some bitmap space based on atlas width and atlas height. So actually let me undo, I just deleted a bunch of code, but what I actually need is kind of similar to that. I don't need this, I do need atlas area, atlas size, image I need. Right there it's clearing the whole thing to black. Why don't I just memset instead? So it'll be all black but also transparent. Then we don't need colors. Now, if I was being clever, I would say that we could do a bitmap with just one channel. Actually, let's do it that way. I feel like being clever. So, atlas size is just going to be that. And, yeah, we'll clear that to 0. We don't need colors count. Let's see. Why was the stride equal to the width? That doesn't make any sense. Should be width times 4, wouldn't it? Yeah, I don't know. But that's okay. None of this is relevant. And then that at the end is actually kind of relevant. Well, let's do it this way. Let's keep the atlas size with a ×4 on it for now, so that I can print out my bitmap and see if my fonts look good. And then we will um, we'll compress it down once I've looked at the test bitmap and made sure it looks right. Okay, so what we want to do now is, I believe I have an array of rectangles. Yeah, right here we have rectangles and rect count. That looks good. So, for all of the rectangles, no, not rect swamp. What is the name of this? Packing rectangle. Yeah. I want one of these. That's that. Rectangles I. So I get each rectangle. And if I remember correctly, if the area was 0, we just didn't output it, right? And we went, alright, if it's got an area of 0, then there's no point in giving this any space. So we just mark that glyph as empty. Otherwise, we actually give it a rectangle in the rectangle packing system. And there we go. Yeah. Now, I don't think I need total area. That was a part of my, sort of half-hearted attempt to make it a little more optimal. Okay. So, let's see. I think each packing rectangle has an identifier attached to it. Yeah, it has an I. So I want to use that I, and that is the code point that I care about, right? So, code point. I'm choosing to represent that. Okay, fair enough, because I'm just doing a few of them. Alright, so code point equals rect I. Alright. So now I've got the code point that I need to render, and the rectangular area that I need to render it into, and the bitmap, like memory, that I need to render it into. So I've got everything I need, right? I just need to tell STB image to do the rendering, in theory. So let's see, foreign, STB, true type, I mean, not image. So, where is there a... I thought there was something near the top that, showed how to do this. Gen textures, no, I don't want OpenGL, I want software rendering. Init the font, get code point bitmap. But that's going to return the bitmap to me. I don't really want to do the blit. I want you to just render into my buffer. Can you do that? Bitmap. Here you're returning it to me. Here you're returning it. Make code point bitmap. So here's my output: width, height, stride, scale code point. That looks promising. Get code, but you pass in the storage for the bitmap in the form of output with row spacing of outstride bytes. Alright, awesome. So, if we can trust STB to render this at the same size that it says it renders it up earlier, then hopefully we can get this to work, right? So what I want is, first of all, where is my font info? Font info, it's up there. Okay. The output is this thing here called image, and it's thinking of that as an unsigned char. So I'll just cast that to uint8t, I suppose. The outwit is the rect. These packing rectangles, they have like an x1, x2, y1, y2 situation. Yeah. So rect x1 minus rect x2, 0. Replace x with y. And the stride. The bitmap is throw spacing of outstride bytes. Alright, good. So it's telling me to do this the way I'm doing it, because I'm calling bitmap box up there, and it's what it tells me to call right there. So I'm subtracting that, and then the stride is just atlas width times 4. Now, this doesn't specify anywhere how many channels it's using, which is a bit odd, actually. I'm going to assume it just does 4 channels, which means if I'm going to do this as a one-channel thing, I'll actually have to do it this way and then compress into a different buffer. Or ask for the buffer somewhere else and then copy it myself with a blit. We'll think. We'll think later. So scale, what is that? Has scale already been set? Yes, it has. So scale, code point. Alright. And then hopefully it can save my bitmap correctly. Alright. TTF to boomp. Right. So let's see, I don't believe I have it here. Let's go looking around with Explorer real quick and see if we can find, I believe it's in, oh, is it in code/data that I've got my TTF file? Yes. Right, okay. So, if I go to data here, there's some TTF files. It's actually outputting something called a BPFT with an extra dot, which is fascinating. 1 second. Where did you get those files? That must have been back when I was running this to get the test bitmap. Look at how small it is. 106 by 107. The whole font. Alright, here we go. So, TTF to boomp. We want to run that on Liberation Sans regular.ttf. So it's all black. Okay. So let's try a couple of things. What if I memset it to be white first? So it is rendering a little bit of black somewhere, at least. Which is interesting and weird. Why is it even colored? I don't know. So maybe it is one channel. It looks like it might be, because it's giving me not all the same colors and things. Let's try that. Let's say... Oh, you know what? I'm totally dumb. yeah, we got to do a couple things differently. So, um, I'll set this back to black, and then let's try. First, let's try fixing the image offset. So, image, or like rect start equals blah. Alright, so I can't just pass that in because this call doesn't have any parameters for where the x and y are, so it doesn't do that computation for me. I have to manually compute the actual starting pixel, like pointer, which is fine. I'm okay with doing that. So image plus equal or plus this is rect.x0 plus rect.y0 times atlas width. Ah, there we go. Now it does appear to be spreading them out. Yeah, so it looks like we've got glyphs everywhere. They look all colory like that because it doesn't realize that it's in a 4-channel bitmap. It thinks it's a 1-channel bitmap. Hey, Strange Zach, how's it going? But like you can see, that's definitely a little E there. If it hadn't been, it is curious. So it's like, why would it be? Actually, that's really interesting. It's like, why is it red? Huh. Like the fact that these are changing colors means it's like that must be a forward slash, maybe, and a backward slash? Why would this be red? That would mean there's only, maybe this isn't an E, maybe it's like, the at symbol. Or something like that. Yeah, because these would need to be squished by 3 pixels if I'm interpreting it correctly. Yeah. Alright, let's see if we can get that to work better. So, how can we do it in a way where it gives me the 4-channel output? Or can I render a... I wonder if I can do like a monochrome bitmap or something. I'm not sure. Okay, so let's do this. Let's make this correct first. So it'll just be a single channel bitmap in my system. So there's the image. Clear it to 0. We do that stuff, and we do that stuff. The stride is just the width of the whole atlas, and then when we're outputting here, what we'll do is we'll do uint32 bumpmem equals malloc atlas size times 4, and then I will just do a loop, right? That's like, look, for I equals 0, I less than atlas size, right? Plus plus I, and then what we need to do is bump mem I, that needs to equal oxff 0, plus like p bit shift 6 bit shift, yeah, 0 8 16 plus p bit shift 8 plus p, where p equals you know, the original image at I, right? So we'll make it all solid in the bitmap. We'll give them all full opaqueness, and then white or black based on whatever came from that pixel. And then instead of image here, I will pass along the bump mem. Alright, if there's no objections to that, it wouldn't matter if there were. We will go ahead and look at this no matter what. Hey, hey! So that explains something. It's upside down. But it's only upside down because Windows is a dick, right? If Windows wasn't cocking me right now, this would be fine. But let's make sure that it's got all the symbols in it. Because when I don't care if it's flipped, because when I read it back out, I'm gonna assume that I know the pattern it's in anyway, right? Like, I don't need to unflip it if when I go to read it, I knew the pattern it was written in the first place. I'll just use it correctly, you know? But, and bottom up is, although bottom up is the way, yeah, well, we'll see. We'll see. So there, let's see if I can track down all the glyphs, because I'm still surprised that it fits in this small space. So there's a 1 here. Does anyone see a 2? 2. Where's the 2? You know, I actually have access to these tools right now, so I can look at it right side up, but now it's backwards. Can I flip it? Man. So they've got rotate, but they don't have flip. Oh well. So let's go back to doing that upside down, I guess. There's a 1 right there. 4 and 7. We need. There's a 3. We need 2. Where's 2? There's got to be a 2. This won't work without a 2. I think that's a 5 and a 6, an 8 and a 9. You can see a lot of small characters got packed in there using a couple tricks. But I can't see the 2 got written anywhere. Oh, 2, here it is. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and then that looks like a 0 to me. Alright, and we've got A, B, D, E, F. Where's C? C, yeah, this looks like it worked. G. G, H. Now here's a question. Why does this look so bad? Is it because I'm zoomed in on a really small font? Because like when I zoom in, why is it... I guess it's because it's not hinting, right? It's anti-aliasing but not hinting. Because like that right there is weirdly wide and faded. But that's fine. Let's actually increase the size because 16 is kind of small. I think that's the pixel height I'm using. Let's do like 24. Because STB TTF works better at larger fonts anyways. Yes, awesome. It totally laid it out differently. It still fit in like a bunch of tiny things. Look at all the little things it fits in underneath other characters. It's so cool. It's so neat. It's got like a little comma there or a single quote. I think that's the comma maybe. Wow. No, that's a semicolon. And then there's a period and a comma and a minus sign, I think. Underscore, tilde, quote. I don't know what that would be. If that's a single quote, then what's that? Is that the... I can't be... Maybe that's an accent mark? Not sure. And that could be a comma. But yeah, this looks like it works. So, now the goal is to make a file format that is pretty simple, that has the, we can also get rid of this. So I'm satisfied with that. Let's say that that's working. We can get bitmap magic out of here now. Bump. Doop. Doop. Alright. So, yeah, alright, so now we're back to just the TTF to bump, but I'm not actually putting out a bump, I'm putting out something called a BPFT, but apparently I'm putting it out with 2 dots in the file name, so let's take a look at that first. How did that even happen? Get files is the thing that actually decides what the files that I'm inputting and outputting should be. Here I get the file extension. If it's a TTF, I move on, and then I plop in the source file. Blah blah blah. The dest file becomes dest file name. Where does dest file name? Okay, dest file name base. I allocate the memory there. Dest file name becomes make string cap. Dest file name size. Okay, so that's just making a string with this capacity. And then it copies the file name to there. It removes the extension. When it wrote the extension back on, it put another dot in there. bpoofed. Now, bpoofed stands for bitmap font, and the reason it's not BMPFT is that would be like boomfed, and that's not as much fun to say as bpoofed for me. So that's why that worked out that way. So, come down here, we've got the image that we want. We know its size in bytes. And then we need to store the, basically the rectangles. Although you know what I'm not doing right now that I should be doing. Where is the pack width, pack height? The glyphs have a width and height. Do they ever have... Do I ever store for these glyphs x0, y0, y1, x0, x0, y0, y, x1, y1, right? I have width, height, pack width, pack height. What is this? What is this? This is glyph packing data. What does glyph packing data even mean? That's like a complicated version of glyph. So I need to create this glyph data array. This glyph data array is basically for each code point that I have a glyph for. I generate one of these. I have some sort of table that says here are the code points that we actually have. So if you want to look up, like, do we have code point for number 10, it looks and goes, 0, no code point there. That'll just be 128 bytes. And then we have one of these for each code point. And we store the boxes, the x offset and the y offset from the packing data here, and the x advance of that. Oh, you know, yeah, so that'd be whether or not it exists, which is different than whether or not it's empty. If it's empty, it might still have zeros all the way through here, but have an x advance. That's like the space case. So there we go. Let's take a look then. How are we going to do that? We need to get an array of glyph datas at some point, and the font thing. Alright, we don't need STB anymore, actually. We've done everything we need with that, so let me pull this up twice. And I will look at glyph data right there. and font data. So I need to store one font data, one glyph data, and what I should do is when I'm storing font data, let's store a little bit more information. So the font data also should include the um, uh, the atlas size, I think, right? And the it should store the the code point count, and it should store the code point exists table. There we go. So really what I need to do is for each of these, I should tell it what code point it's using, and then at runtime I'm gonna blow that out. The other way to do it is instead of putting the code point in each of those, I make these into ints so that I can say, oh, you want the nth glyph data. I think I like the other way better. So glyph data will tell you what your code point is, and then you just loop across. The other code can just loop across all the glyph data and decide what to do about that. Then seems easier for the other end that way, and kind of easier at this end maybe. So we need to start setting those things up. So I'm going to put a little thing there to mark building the bpuft data. There we go. So here's the font data. Here is the for the glyph data, we basically need glyphs, 128 of them, and we're not going to use all of those. We don't need to use all of them. We just need the space for that many. And the glyph count, I think we actually already have, don't we? Actually we don't. But that's fine. What we'll do is just do that right here. Glyph count equals 0. Or code point count. Yeah, I think glyph count makes more sense now that I think about it. Well, no, because not all of these actually have a full glyph. It's more like this is code point data. There we go. And if I run across all of the glyphs that I have, glyph packing data, I should be able to answer the rest of these questions. So I is less than max code point. I should also put that right here actually, plus plus I. And then what I do is I get the glyph pointer, like so. Or actually, the nice way to do this is start there and then plus plus the glyph at each step. And then if that glyph exists, Then I increment the code point once I've got a code point uh, data structure. So let's call those code points. Code point count, right? And I take the pointer to that. And let's see, for each one of those, I take my code point data and I want to set the x0, y0, and so on and so on. But I don't want to do, I've got the rectangles that I'll have the x0, y0, x1, y1, but I have the glyph packing data that has x offset, y offset, x advance. And it's not totally clear what will be the easiest way to handle that, because they're not in the same order. So what is true is that the code points do not let me look up a rectangle right away, but they do let me look up a glyph packing data right away. So what I want to do is actually not this. What I want to do is loop over the rectangles first. Rect should be my rectangles. Alright. And for each of my I equals 0, I is less than rect count. We plus the rect, and then what I do is say, alright, what we need to do is increase the code point count, get the code point data, set the code point data code point to the rectangle I. Similarly, x0, 3, 4, turn the zeros into ones. Hey, turn all of those zeros into ones, turn all of these x's into y's, and turn all of these x's into y's. And then I can look up into this structure here, in the array of this structure, and get out the rest of the information. So it's like, well, I maybe want to take my code point here. 32 code point equals rect code point. And then I want to go to glyph packing data. Somewhere down here, I have a packing data array where I put in a code point, like so, and out pops a glyph packing data. Alright, and now if I come back up here with that packing data, I have the rest of the information I need, which is the code point data x offset equals the packing x offset. Turn all those x's into y's, and then turn all of those x offsets into x advances. Alright, so I've now got all of the code points that have rectangles, but I don't have all of the code points because there are also a subset of code points that do exist and have an x advance, x offset, y offset, but not a rectangle. And what I should do if I want to be clever is I'm going to make a special little array of those guys. So this will be the empty packing data, right? Empty packing data struct. And that just means it stores that much, right? And Yeah, and then what I need to do is I need to make an array of those up here with the glyph packing data. Call this the empty packing data, and I'll have one of each of those, and I'll have a little counter here called my empty code point count, which is 0. And if I set the glyph is empty, then empty packing data, empty code point count, this goes ahead and gives me an empty packing data, and then I will fill that out with these 3 fields here, like so, except that instead of that, it is the empty struct. D7 Samurai asks about why I'm back on a monospace font, and the reason is because the auto indenter looks better on monospace. Once I have a code mode where it will show code it will show indentation, but not by adding spaces, but by like, this would be like one white space character, or like no white space at all, and it would just say, oh, this is supposed to be indented this far, so it draws it there. Then I'll switch back to monospace, because then it will be able to line things up by the pixel, but without, but then things like, if you have like this right here, where it's lining these up by spacing all of this, it just like looks like this, right? Like I can show you real quick what it looks like. It just looks like ass, because it doesn't know how to line these up by pixel. It just tries to keep the same number of characters. So once I can line those up correctly, I will switch back, and I will also pick a better font than this. But for now, I'm on this. Let's see. Okay, so we have added all the data for empty glyphs, and now down here, once I'm done pulling out those ones, I can do a second loop that just goes for I equals 0, I less than empty packing data, or empty code point count plus plus I. For each of those, I get an empty. Oh, that needs to know its code point. 32 code point. There we go. Let's go back up there. X advance. Come on, empty X advance. I need to set the empty code point equal to the code point. There we go. Now what I can do is pull out the rest of these. I need something that looks like an empty packing data empty equals the empty packing data I, and then basically I just need to set this and all of these. And the way I do that is by going into the empty struct. And like so. And for the future, I'll line all of these up, but I want to do it like this. I wonder if I could make a code manipulator to do that kind of crap automatically. Like say, give a range of lines and say treat each of these as an assignment, find the equal sign on each line, and align them. So I do that once in a while, so that I have stuff like that where I can do the multi-line editing. Okay. Anyway, so we've got all the code points. The one thing we haven't done is I should be getting the code point data out of this, like that. And before all that, let's mem set that all to 0, just so that the unspecified fields here will be zeroed out correctly. Um, D7 Samurai asks if I added the feature for aligning the equal signs, would I somehow tag that so that it stays aligned, even if you were to, like, rename this to have underscores, that it would automatically realign them. I'm not sure what I would do. I've thought about that. Like, you could do something like putting a little comma in here. It's like note, or like for coder note, align, or you could do something more subtle, like a small thing that's just like, like right here, begin align, or just like a code that doesn't make any sense, like BA, for whatever that means, right? It's like begin alignment, whatever, and then end alignment. You somehow mark up that code so it knows to do that. And it has to be written into the code so that it knows, or make some kind of metadata file outside of the code that remembers all of the files you've ever edited on this computer, and then remembers things like that. But then if the files are different, you have to like somehow go, oh, this changed, and adjust to it. So I don't really like either of those situations right now. I think what I would do instead is just say if it should be easy to invoke that. So it's like if you edit these, just edit them and then select them again and do it again. If I had code mode, I would go a little bit fancier and say that there might be such a thing as like notes that are built into the code. So it'd be like a for coder note. That'd be like for coder note, align begin, and it'd be like align the equal signs or whatever, right? And you would actually write that into the code, and then the editor would hide that for you. And then if you didn't like the fact that your code had hidden comments in it, you just like don't use that feature, like turn it off. But that's an idea. But yeah, I imagine if it's just easy to invoke, then probably the best thing to do is like every time you're done editing, you just go, all right, click click, like a line paragraph. I'll probably get to the point where I just have a thing that like auto senses things like this anyways and says like, oh, this is a table. Um, so it wouldn't be a matter of surrounding the entire paragraph. It would just detect where the paragraph is, kind of. I don't know. I have to think about that some more. There's a lot of different ways you could do it. The other thing you could do is eventually get to the point where you do keep the external metadata and do a diff. Like your external metadata somehow has to know the last state that it believes the file was in, and then do a diff against what the file actually is now, if the file has been changed since the last run, so that it can correct those things. Which is kind of sounds crazy, but if you have like I don't know, like your versioning system built into forcode or somehow, maybe you could do it. I don't know. There's a lot of possibilities. I don't know. Anyway, so we've got all of the code point data filled out, and we know how many code points there are. We need to fill out the rest of the font data now that we know everything about it. So we know the atlas size. We know the code point count. We know the line height, I assume, although I guess I don't know that we know the line height. Did I store that earlier and just like forget about it a long time ago? Line height? Like V metrics. Ascent. Is ascent the one I want? Let's go read the STB stuff. V metrics. That doesn't tell me anything. V metrics. What do you got for me? Ascent is the coordinate above the baseline the font extends. Yeah, that's not the only thing I need to know. Why is this text formatted this way? It's kind of odd. Anyway, descent is the coordinate below the baseline the font extends. Okay, so this is like if you've got a baseline, ascent, descent's a negative amount there, so ascent minus descent gives you all of that. Ascent minus descent plus line gap. So ascent is up here, descent is down there, gives you the full height of the rendered line, and the line gap's a little bit more. Okay, fair enough. Let's just grab all of those. Descent equals 0, line gap equals 0. Pass that all in right there. Descent line gap. Then it says I gotta multiply these all by the scale. Okay. So we'll call this like ascent F equals ascent times scale. Ascent descent. Ascent line gap. And then finally, line height F is just ascent minus descent plus the line gap. And each of these need the F version. And then finally, the line height is the ceiling of the line height F. There we go. And then code point exists. So that's the last thing I gotta do, which is I need to set all of that to 0. And then I'm gonna do a loop across all of my code points. And each one of those code points is gonna say, aha, this one exists. And to do that, I just take the code point out of the code points. Come on, code points I dot code point. Not 100% of those names were perfectly named, but that's okay. Descent, descent, descent. Round 32. Seal 32. Alright, the easiest way to do a ceiling, what would it be? If it's negative, you just trunk it. If it's positive, you see if it's equal to an integer. And if it is, you just use that. Otherwise, you... yeah, that'll work. Whoops, get out of here. Alright, if x is not less than 0, then if int... well, let's do it this way. First we'll set this, like so. If x is greater than 0, then what we'll do is we'll say, alright, if r equals, if float r equals x, then we do nothing. But if it does not equal x, we add 1. Then we return r. Alright, so there's a nice little hack together seal 32. Wouldn't that, Fiery Drake suggests a slightly simpler thing, but my question is, wouldn't that fail if I set x to, for instance, equal to 3? Wouldn't that give me a 4? Yeah, properly rounding with, like, handling all of the possibilities of float is actually, like, I'm sure an awesome thing to spend a lot of time on, and you know, come out the other end with something that transforms 4 bytes into 4 other bytes in, like, one of the most complicated ways you can imagine. But I just, like, don't try to be fancy. I just write the ifs and get it over with. Normally converting from float to int in performance critical code is probably not great anyway. You probably want to get that done somewhere else in the pipeline, I imagine. So I just let it be slow and iffy. By iffy, I mean have lots of ifs. I never bothered to learn how to do it fast. There we go. Whoops, that's just an I in the case of rect. Alright, there we go. So that is, in theory, building out all of the data I need. So now all I need is, like, because, let's see, font data and code point data actually build out what I need to know about the font. But what I don't have yet are, or is the, like, file header type. So type def struct, we'll call it bpoofed header, right? And that'll contain, like, file type. Then I'll put font data position. I'll put in the code point data position. I'll put in the atlas position. And maybe a version. Alright. So, let's see. Little, like, magic number sanity check there. Then put in the code point, or no, the version number as 1. font data position, code point data position, and atlas position. Now to get those, what I need to know is how I'm going to lay these out, and the reason I'm doing this is because I want to lay them out like on 32 byte boundaries maybe. Well, this is for, I could probably do 8 byte boundaries to make sure everything lines up just well enough. So let's do it that way. Int 32 position equals 0. Position plus equals the size of the header. Position equals position plus 7 divided by 8. Right? So that rounds me up to the next multiple of 8, and then, and I could actually divide by 8 more quickly, couldn't I? Because that's like a bit shift to the right. But I don't want to divide by 8. I want to. So I want to divide. Oh, it's like a modulo 8 is what I mean. Which I still feel like there's a way to do that too, right? Modulo 2. What is it I want to do here? I add 7. Oh wait, it's, you add the 7 in if it's, that rolls you over this position, and then if you took modulo 8, now that'll make it too small too. It's like I want position plus 7 minus position plus 7 modulo 8. But I feel like there's an easier way to do that. Like if you do that for binary, if it's just 2, what happens? Right, if it's modulo 2, you're either subtracting out a 1 or a 0. Oh, you're subtracting out the lowest bit in that case. And if it's a 4, you're subtracting out... Oh, right. So it's like I want to mask out the lowest bits as determined by... Ah, I see. So it's like I want and bit not 7. That should round me to the nearest 8. Boundary of 8, and then I can put in the position there. So there we go. Then I advance forward again. This time I'm increasing by the size of font data, nearest multiple of 8. Then I need to increase by the size of code point data times the code point count, and then multiple of 8 that, and position. And now I'm ready to write out the whole thing, because I can find out my file size by I take the current position plus the atlas size, or what I could do is just keep the same pattern I had before, right? So add in the atlas size, and then round to 8, and then that's just the position, right? And then I can get like file, or let's do it this way, because it's not really a string. File data equals malloc file size Let's memsat that to 0 because there's going to be little spots in between. I want them all to be 0 for niceness. File size, and then we'll take uint8t write putter equals file data, and then I do cast that to or like I can do mem copy into the write putter from the header, the size of the header, and then I can do write putter equals the file data plus the offset of this, right? And right pointer plus the offset of that. Then I can mem copy into it from the font data, just called font, size of font. Then write putter equals the file data plus the code point data position. There I mem copy into the write pointer from the code points array with the size of one code point data times the code point count, right? Then finally I do one more where I use the atlas position and I mem copy into there from the image pointer the atlas size, right? So that right there wrote all of the file's data out into a buffer, and then we can just fwrite into files.output file data 1 file size. Okay, so it looks like yeah, that looks like it maybe worked. Not sure why that thinks it's a 4-coder file, actually. It's a bit odd. It's not, definitely not a text file of any kind. It does make me curious. You can see that right there, and then the rest of this is totally broken and bad, but that's fine. It's expected. So that's like that's a 1 right there, right? Little endian, so the smallest thing right there, that's a 1. Interesting that 1 is renderable as a block. I guess that's the like missing the glyph not found symbol. Then I put nulls in like that, and another 1 happens. If I'm interpreting correctly, what is my header look like? Font data position, version. Why would font data position be a 1? Maybe that is capable of being more than just 1, because yeah, maybe there's a couple glyphs that look like that or something. Not sure. Right there, there's a character that's invisible, and then 3 more, so that's actually 4 bytes. And yeah, there's another 4 bytes, and so on and so on. Alright, so I don't know if it worked or not, but the good news is that it kind of looks like it maybe sort of worked, and I don't have any good reason to believe it didn't until I start trying to load that on the other side in the game code. But I think I'll leave that for the next time I do a Cipher Drive stream, because I am satisfied with just getting that done today. So thank you everyone who took some time to watch me working on this, and keep in mind that this Wednesday I will be making an interesting announcement for 4Coder, so come check that out then, and I'll see you guys later. Bye bye.